Hi, dear viewers. Yeah, again, we will come back. We will do physics numericals. Okay. This is current electricity, chapter 8. 8C, numericals. We are continuing. In the first part, we have discussed up to 14th question. Now, 15th question onwards, we are going to discuss. Okay. Yep. Question number 15. A bulb is connected to a battery of potential difference 4 volt and internal resistance 2.5 ohm. A steady current 0.5 ampere flows through the circuit. Now calculate the total energy in 10 minutes, resistance of the bulb and energy dissipated in the bulb in 10 minutes. Okay, so first case voltage, internal resistance, current and time. 10 minutes means 600 seconds multiplied by 60. Now energy supplied by the battery V times I times T. Current and voltage we know, right? So V times I times T. So V is 4, I is 0.5 and T is 600, so 1200 joule. Okay. Next is resistance. Resistance of the bulb they are asking. So here, yeah, how can we identify this one? This V is the potential battery. Battery of potential difference V 4 volt. That is what they mentioned. A bulb is connected to a battery of potential difference 4 volt. So that is the total EMF. Okay, so that will be IR plus IR. R. So small letter R we got. That is internal resistance. They had given internal resistance as 2.5 ohm. So total resistance will be R plus R. So that resistance of the bulb we don't know. Then the internal resistance of the battery is 2.5. So R plus 2.5 will come. I is 0.5 and V is 4. Okay. So when we substitute V as 4, I as 0.5, R we don't know, small r as 2.5. Then distributive property 0.5 times R is 0.5 R plus 0.5 times 2.5, that is 1.25. Then solving for R, that is 1.25, we can bring it to the other side. So 4 minus 1.25, that is 2.75. Therefore R equal to 2.75 divided by 0.5, that is 5.5 ohm. Next is energy dissipated in the bulb in 10 minutes. So E equal to I square RT. So current value we substituted, R resistance we substitute as time as 600. So 825 joule. Okay. Yeah, that's it. Next is question number 16. So two resistors A and B of resistance 4 ohm and 6 ohm respectively are connected in parallel. Combination across 6 volt battery and power supplied by the battery and power dissipated in the each resistor. That both case they are asking. So parallel connection means what is the effective resistance? We need to find out. So 1 by Rp is equal to 1 by 4 plus 1 by 6. That is 5 by 12. So reciprocal Rp will be reciprocal 12 by 5, that is 2.5. So equivalent resistance will be 2.4 ohm. Now first case power supplied by the battery. So P equal to V square by R. 6 square by 2.4. So it is 15. So power supplied is 15 watt. Next is power dissipation across each resistor. P equal to Vi. Okay. Each resistor they are asking. So current through current across A resistor is 6 by 4. Power by volt, no, so 3 by 2, 1.5. Then power dissipation across A. So V times Ia. So 6 times 1.5, that is 9 volt. Similarly, current across B. 6 B resistor, that is 6 ohm resistor. So the same way we can apply the formula, and current we will get it as 1 ampere. Okay, 1 ampere will be the current. Now power dissipation across B is V into I into B. Okay, so when we substitute, 6 watt will be the energy consumed. Okay, now question number 17. A battery of EMF 15 volt and internal resistance 2 ohm connected to two resistors of resistances 4 ohm and 6 ohm joined in series. Find the electrical energy spent in per minute in 6 ohm resistor only. Okay, so battery's internal resistance is 2 ohm and two resistors 4 ohm and 6 ohm are connected in parallel. Sorry, series. Series means the total resistance will be all the three internal resistance and other two resistances. So 2 plus 4 plus 6, that is 12 ohm. Okay, so from Ohm's law V equal to IR. So V as substitute, V as 15 and I we don't know, R will be 12. So I we will get as 1.25 ampere. Then voltage across 6 ohm only. So V equal to I times R. In that case parallel, current is 1.25 ampere times 6. That is 7.5 volt. Next one is like yeah, potential voltage across 6 ohm is 7.5 volt. Okay, now time is 1 minute, that is 60 seconds. So we know energy is V square T by R. So we can substitute, right? V as 7.5, time as 60 and R is equal to R. So energy spent across 6 ohm resistor is 562.5. So this calculation you should have to do, no other way. Okay, calculation part you should be able to do. Multiplication, division, like that things only. But by practice only it will be easy for you. Okay. Now question number 18. Water in electrical kettle. Electric kettle connected to a 220 volt supply takes 5 minutes to reach its boiling point. How long will it take if the supply voltage falls to 200 volt? Time. Okay. So same electrical kettle only. So 220 volt is the supply, means 5 minutes. If 200 volt means how much time, how long it will take. So power is equal to V square by R. Yeah, when we substitute heat equal to P into T. So heat energy will be V square by R times T. V is 220 volt. Okay, we are substituting all the things. And we will get two equations. First case, what is heat energy? Second case, what is heat energy? And that two ratios we can equate, because both case heat energy will be produced will be same. So both the energy produced will be same. So but we need to check it. Equation number 1 and equation number 2 are same, and that is 220 whole square by R the whole square times 300 equal to 200 by R the whole square times T. So from that T we can find out, that is 363 seconds. Okay, that is the total time taken. That is 6 point divided by 60. If you do it will be 6.05 minutes. Okay, now question number 19. I think it is direct questions only, just V square by R T, heat energy. Both case we are finding and equating. That common factor will cancel and the unknown value we can find out. Okay, question number 19. An electric toaster draws current 8 ampere in a circuit with source of voltage 220 volt. It is used for 2 hours. Find the cost of operating the toaster if the cost of electrical energy is. Okay. Find the cost of operating the toaster if the cost of electrical energy is 4.50 rupees per kilowatt hour. What are the given conditions? I given to 8 ampere, potential difference 220 volt, and time is 2 hours, rate of electricity 4.50 per kilowatt hour. So we have the relation E equal to VIT. So cost of operating if the electrical energy. So anyway, electrical energy we need to find out. So E is V into I into T, just 3.52 kilowatt hour we got it. So for 1 kilowatt hour 4.50 means 3.52 kilowatt hour, just multiply by 3.52. Okay, so now heat energy, cost of electrical energy is 15.84. Now question number 20. An electric iron is rated 220 volt 2 kilowatt hour 2 kilowatt and 3 hours daily. Okay. For 1 week it costs 4.25 per kilowatt hour. So find the cost for 1 week how much. Okay. This is 3 hours daily using. Actually for 1 hour how much we need to find out. Okay, energy is P times T, so 21. Okay, total time they calculated. So 1 hour, 1 day, 3 hours, like that. 1 week means 7 days. 21 hours they are using. So from the relation E equal to PT, we got it. So for 42 kilowatt hour. So cost for 1 kilowatt hour is 4.25. Therefore, for 42 kilowatt hour means multiply by 42, 178.50. It's a direct question only, no? Look this. Now question number 21. A geyser is rated 1500 watt 240 volt. This geyser is connected to 220 volt mains and calculate current electrical energy consumed in 50 hours cost. Okay, so power and voltage given P by V, I we will get. So current we will get. So 1500 divided by 250, 0 and 0 will cancel. So 6 ampere. Now energy consumed in 50 hours. 50 hours. So multiply by 50. P times T. P we already got. Time is okay 50. Substituting the values in the formula above, we get E as 75 kilowatt hour. Then cost for 1 kilowatt hour 4.20. So total cost will be multiply 7.5. 75, right? Yeah, 75 times 4.20. Okay. So the total cost of energy consumed is rupees 315. Okay, I think the explanation was clear and all of you understood it. So you please write the notes. Once again, you watch this video and write the notes and listen the explanation. So you will understand it very clearly. Okay, and I feel like it is all these questions are simple questions only, direct questions only, right? Not like mathematics. Physics is very simple. Okay. Yeah. Thank you.